So I'm not going to go into depth about how to create this network and how to model the parameters. These can very quickly be done by looking at our other videos. Now, having set this up, what we will now do is we will run the simulation. So when you run the simulation, it automatically says that we can start MATLAB. So we press a key and automatically MATLAB starts up. And you can see this plot where currently it is showing that secondary user is in channel 54 to 60 in base station 1, and it is in channel 202 to 208 in base station 2. Here a primary user comes on, but the secondary doesn't shift as of now because the frequencies are different. So it's now about 4 seconds of simulation is okay. It's at point, yeah. So now you can see that when the primary user came on in base station 1, the secondary user shifted from 54 to 72. So in the top is the base station 1, where you can see the shift in secondary user as the primary user comes on. Interestingly, in the second set of graphs at the bottom also, the secondary user is shifting, but that is happening because of false alarm. That is, it is falsely believing that there is a primary user in that particular frequency band, and hence it is shifting. So here on top you can see that the second primary user came on, so the secondary user shifted back from 72 to 78 down to 54 to 60, because as per the rule, it cannot even use an adjacent channel. It must be at least 2 channels away. Again, when it came back to when the primary user came on here, the secondary user shifted there. So similar to this, you can use this code that we have written to have for any number of primary users, any number of secondary users, any number of base stations, and so on. And in real time, you can understand how the shift in secondary user is happening. You could also make a note of the exact time at which this happens, and then with that you can do things like there's research going on the time taken for the sensing to happen. And there's research going on how to reduce the time for detection. So all of these details can be graphically visualized using this tool. Otherwise, all this information is available in NetSim, it's available in the trace files and so on, but it's not there as a convenient visualization. And through these examples, we have attempted to show you how to do data analysis and data visualization at the now at the end of simulation, there's another plot. So we just terminated that simulation, and here what you can see is this is across time. The earlier plot was at runtime, but this is across time. So here you can see that initially the secondary user is there between 54 to 60. It is operating here, but as soon as this primary user comes on, it shifts up to this position, and then at this position, somewhere another user comes on, another PU, so this drops, then this comes on, so at that time this goes up. So this is what is happening in the first base station. The second base station, of course, it is on the whole time, the primary user, but this is a totally different frequency band compared to this. However, you can still see some transitions, and this is occurring because of false alarm that this is microsecond into 10 power 7. So at 5 seconds there is, or at about 6 seconds, there's some false alarm, so it jumps up. Then there's another false alarm. So 1% of the time there is false alarm. So the effect of false alarm can be analyzed with this. So this is to give you an idea about how you can do R&D on cognitive radio networks and analyze the same using NetSim. And with that, we complete about 45 minutes of this webinar, and we'll spend about 15 minutes in answering the various questions that you have. Yeah, so please write your questions via the chat window and we'll answer them. Okay, so earlier I was supposed to tell you about how to do random deployment. So we'll show you how you can do random deployment. So here you can either do uniform placement or random placement. So suppose I select random placement and I put some sensors. So you can see now all of these are placed randomly. So this is how you do random placement. Then if you want to know how to set the power model, somebody had asked. So here you have the power model. So you have battery or main line, and then you can set on or off energy harvesting. Then you have initial energy, transmitting current, idle current, voltage, receiving current, sleep mode current, and so on. So you can set all these parameters and then analyze what is the power consumption in the network. So I hope that answers questions related to random deployment and power. Next, we have a question with regards to VANET. Yes, we have VANET simulations where VANET can be linked to Sumo, which is a do we have Sumo linked in this? We can show just the thing. Yeah, we'll just see if we have Sumo linked, we can show you. That so what happens is that as you run NetSim, automatically Sumo is also run, and this is the Sumo software where you can set up the road traffic simulation using Sumo, and NetSim will do the network communication while Sumo will do the road traffic simulation. So this is the road traffic simulation in NetSim, in Sumo, and the equivalent of this scenario is being shown in NetSim, and this is used for vehicular communication. So it runs on 802 I'm sorry, on IEEE 1609, which is Wave and DSRC. That is used for vehicular ad hoc networks, and there are some Traci APIs that are used for interfacing Sumo and NetSim. Next, what is the highest value of false alarm? You can set false alarm up to whatever value you want in NetSim, because NetSim is a simulation software, so you can set it from 0 to 100%. If you set it at 100%, every time it detects, it'll be showing a false alarm. But the typical research going on is, how do you write the detection such that false alarm is at its least? Currently they are, it's at 1% or 0.5%. So research is going on how to reduce this further. Sometimes if you reduce the time for which you can sense, then the trade-off is that false alarm might go up. If you can sense for a longer time, false alarm can come down. So there's a trade-off between the two that will need to be optimized. Next, is it possible to find intruder IP? Yes, I mean, we have some example projects on our website where we have about security attacks. So if you go to our file exchange, we have a number of R&D projects with documentation and source code. And here we have one project which talks about sinkhole attack in AODV. So in this particular example, you can understand sinkhole attack and then check what is the IP and so on about that using wireshark. Next, can we send multimedia packet using LTE and WLAN? Definitely. We have in NetSim, we have voice, video. We'll just show you. We have all kinds of applications that you can use. So here you can see we have email, HTTP, video, voice, database, FTP, peer-to-peer and emulation, where you can connect NetSim to real devices. If you want to send real traffic through the software, you can use emulation for that. And under video, we have a number of video models. So you can see different mathematical models for video, and based on this, video traffic will be generated. So the answer is yes, you can definitely send multimedia packets using LTE and using WLAN. One more question is, what happens when a packet is lost? In NetSim, what happens is that since it is virtual, that particular packet is it is just freed. That memory location is freed, and the packet is freed from the memory in the simulator. But all the details about that packet, when was it transmitted, when did it get lost, all its history is stored in the trace file so that you can use it for your analysis. Then there's a question, does NetSim support IoT simulation? Yes, we have support for IoT in NetSim. And so you can see over here, Internet of Things, we have support for that. And in IoT, we currently have various protocols, and there's a new protocol called RPL, Routing Protocol for Low Power and Lossy Links, that is expected in our next release in V10, probably towards the end of this month. Then we have a question, is there any method in which we can find intrusion detection and prevention? Yes, we have a project exactly on this, where we have, we'll show that to you. So you can see it over here, intrusion detection system for VANETs. So here we have an intruder, and the intrusion is detected using, I think, path rater and watchdog algorithms are used to analyze the intruder and then to prevent the thing. We have a video on this as well in our YouTube. I think it's in a different playlist. Yeah. Yeah, so you can see, so you can see the video there, creating malicious node, simulating and programming thing, and then we have intrusion detection that will happen. So if you look through our playlist, this information is available about how an intruder is there and then how the intrusion detection system works. Can we modify the algorithms? Yes, NetSim comes with source code, and the entire source code that we showed you, it is there in the install directory. So if you go to the install directory of NetSim, there's a folder called SRC which has the entire source codes. So here we have given it to you in a neat format where you can just open this, and you just open the SLN file. You have all these protocols, and we have source codes for each of these protocols. So for example, if you see DSR, you know, this is the DSR.h source code. The code is all written in C, and the code will be written exactly as per the RFC. So you have each of the packets and so on. Then you have the C files which will do the DSR routing and so on. So if you want to change anything in the MAC layer, you can change in 802.11, or you can change in Ethernet, or you can change in 802.15.4. So depending on which protocol you're using in the MAC layer, you can make necessary changes to the C code. Then we have a question whether sinkhole attack on leech protocol is given in 9.1. Yeah, leech is there, and we have a sinkhole attack on DSR. So I think with some minor modifications, the same thing can be done for leech. It's probably a few days work to just port the regular sinkhole into leech. I think it can be done, and yes, 9.1 is required to do that. The latest version is what will be required for running that attack. Then can you connect NetSim to real hardware? Yes, we have an emulator. So using the emulator, you can connect NetSim to real systems and send real traffic through the simulator. and you can do your data analytics, visualization, everything using using real traffic running through NetSim. Then what is the price of NetSim? Well, we have number of versions. We have a pro version for industry and defense. Then we have a standard version that is used for R&D, and then we have an academic version that is used for lab experimentation. So if you could just write to us at sales@tetcos.com or go into our website and send us an inquiry from there. Then depending on which version you want, how many licenses, what technologies you want, and so on, there are different prices. But for educational institutions, we sell at discounted prices for research and for academic use. So if you write to us, and if you can send an official email from a university mail ID, we can provide you with the discounted pricing. Okay, if there's any other questions, last one or two questions I can answer, and then we'll be closing the webinar. What is the latest WLAN version? We have 802.11 A, B, G, N, and the latest is AC, which is gigabit Wi-Fi, and it also comes with 11P, which is used for vehicular ad hoc networks, and 11E for QoS, but the latest is 11N and 11AC. And similarly, yes, we have support for LTE advanced as well. And in NetSim V10, which is expected towards the end of this month, we will have support for the 5G components that are there, which is device-to-device communication, and for femto cell. So LTE will have basic LTE, LTE advanced, LTE device-to-device, and LTE femto cell. Yeah, all these codes for these projects are there in that file exchange. So if you go to our file exchange, you will see a Word document explaining how, what is there in the project, what is the codes and all that, and how to run it. And then you will have the necessary C files, which will contain the project codes. So we have more than, I think, 30, 40 R&D projects which users can choose from and build on that. So typically researchers use one of those examples, and based on that they make code modifications. Of course, for all our customers we have tech support as well, so you can just send us your research papers or the codes that you're working on, and to the extent possible we can look at it and get back to you with comments on how it can be improved. Certificate of participation, yes, you can just write to us through our support at tetcos.com requesting for a certificate, and you will get a certificate from us. So what you'll have to do is just send us a request from our website. If you go into support, if you go to knowledge base, you can go here and raise a support ticket, and if you just say that over here saying that you need a participation certificate, within a day or two our technical team will get the certificate and send it to you. There are some questions about NetSim version and so on. You can just put any version that you want in that support ticket section. Don't worry about that. You can just put anything you want and send it, and we'll give you the certificate. So thank you all for attending this webinar. We'll have monthly webinars that are there from our end, and please feel free to join in any of our future webinars. All our webinars are also recorded, and recordings are available in YouTube. So if you're interested, you could also look through some of our earlier recordings. Thank you all.